Hi students, welcome to my kitchen. Today we're cooking up a discussion about AC compressor replacement as well as repair procedures. So I brought this AC compressor into the kitchen table here just to disassemble the clutch of it to show you what actually comes with a compressor, a bare compressor versus a complete compressor when you buy it from a parts store. Um, so most of the time, most technicians, when it comes time to replacing a compressor, will buy a complete assembly, which has the clutch and the compressor in one box. Sometimes it's actually cheaper to do it that way than to buy even just a clutch assembly. But you do have the opportunity or option to buy just a clutch or just a bare compressor or all of it in one box. So here's how this works. This is a typical AC compressor clutch assembly that has the clutch that is electromagnetically controlled. Most compressors are set up like this. It has two wires going to the compressor clutch assembly, and it has a freewheeling pulley. Notice when the pulley spins, the compressor itself does not spin. The compressor only spins when we engage the clutch that engages the hub of the compressor to the pulley of the compressor. So when your engine's on and you don't want air conditioning on, your pulley just freewheels. It's always turning when the engine's on. The moment we want the compressor to turn, we engage this clutch by giving these two wires a 12-volt power source and a ground, and that engages a strong magnet that pulls this clutch in to magnetically hold it from moving with the actual pulley of the compressor itself. So let me take this apart. Most of them just have a simple bolt right in the front of it. You're going to need some sort of impact or a tool to hold this from spinning. They're not very tight, but again, if you're trying to do it with a wrench, it can sometimes turn the compressor while you're doing it. You can do this procedure with the car, with the compressor in the car, but it does make it a lot easier with the compressor off. In some vehicles, there's no way to do this procedure in the car. You have to take the compressor out because there's just no room to do this. So what we do is take out that center bolt, and the hub actually slides out. Now you probably notice a little washer that fell out. This washer sets your clutch gap, your air gap, which we'll talk about in just a second. So I'm going to set that aside. Sometimes the washer gets stuck inside the nose of the hub, and sometimes there's multiple washers. So if you tap it, see if any of them else come out, but just make sure you don't lose that because this size of this washer is pretty important. Notice this side of the hub is a finely machined steel, and then if you look over here at the clutch, once I disassemble it, you're going to see that this is typical clutch material, dry clutch material, kind of like you'd find in an automatic transmission, but obviously it's not wet. That clutch rides up against this hub, and when we squeeze that together, when this hub turns, it turns with the pulley. Actually, I probably said that backwards. When this turns, the hub turns with the pulley. So let me pull this apart. Most often, it's held together with a snap ring. So I brought my snap ring pliers from work. Grab onto the snap ring. Oop, slipped off. You guys get to watch me fumble with this. Sounds like fun, doesn't it? All right, snap rings off. And at this point, the whole pulley and clutch material comes off as one piece. You can see there's a bearing in here. I can hold the bearing and spin the pulley. Sometimes that bearing fails, and when it does, these can get very noisy, but you have to think about when they would be noisy, okay? What this bearing rides on is part of the compressor. This will be more clear when I take off the magnetic clutch, which again is just another bigger snap ring. So I'll see if you can see what I'm doing in here. Yeah, I'm trying to work holding it at a good angle. Okay, just a snap ring there. Once you get that guy off, all that is a coil of wire. Okay, So now this is a bare compressor. This nose of the compressor is what the clutch or pulley rides on. Okay? So as long as the engine is turning, this bearing is being used. So if you have a compressor that's noisy, and it's noisy all the time, anytime the engine's running, this bearing is bad. Okay? Because there are times that this hub, which is supposed to ride near the pulley, but doesn't always touch it, there are times when we connect these together, when we link them together with that electromagnet, and they're spinning as a whole, you could have a scenario where the compressor itself, which is driven by this hub, is noisy. So again, you're going to have to diagnose where the compressor noise is coming from if you're replacing a compressor for a noise concern. Is it the bearing or is it the compressor itself? That's an easy question to answer. Again, is the noise there all the time? If it is, it's your pulley bearing. If the noise only comes and goes when the compressor clutch is engaged, then it's a compressor. All right? So again, your three main parts to a compressor clutch assembly is your electromagnetic device, which really is two wires. Those two wires go around in a coil of copper wire, which creates a strong magnetic field when you're flowing current through it. That sits tucked up in here inside this compressor pulley, and then my hub sits on the other side. So when I engage the clutch, it wants to draw this in, and it squeezes it up against, oh, look there, another little washer fell out. That's what pulls this compressor clutch hub up against the pulley and locks it and begins to turn the compressor on. So again, compressor off, freewheeling, compressor on, locked, and now the compressor's turning. All right, let's talk quickly about setting clutch air gap. So if we reinstall this thing, and I'm not going to bolt it back together, but I just want to show you how this works. The distance between the friction material of the pulley and the steel side of the hub is very important. If there's too much gap right there, the magnet will not be strong enough to pull it in. All right? If it's too tight, obviously you can probably imagine that the friction is going to drag on the steel, and you're going to always have partial engagement of the compressor, or you could have noise, or you could wear or overheat the clutch. So again, we control that clutch air gap with these washers. They simply sit down in here, and they ride between the actual input shaft of the compressor and the hub. How do we know what's correct? Well, you can find that specification from the manufacturer. For instance, if I put this hub back on and I want to measure the distance between here and the friction, I'm going to need a tool, a measuring tool, precision measuring tool called feeler gauges. And you guys should be familiar with feeler gauges. All we do is we find the feeler gauge that fits in between the friction material and the hub. And again, the manufacturer will give you a spec. If it's too tight, we add washers. If it's too loose, we remove washers to make it tighter. Again, that procedure is going to be found in manufacturer service information, but they're all typically set up that way. All right, let's talk lastly about controlling the oil inside a compressor. All AC compressors have oil in them, and that oil is to lubricate the moving parts in here, okay? Without oil, compressors fail, just like an engine would fail without engine oil. So we have to have the right amount of oil. With that said, with too much oil, you can also have compressor failure, because just like adding too much oil to an engine can create engine issues as well. When you replace a compressor, the compressor we take off is going to have oil in it. So we have to determine how much oil was in that compressor and then put that amount of oil back into the new compressor. You have to remember that all AC systems have a designated amount of oil. Sometimes it's around 6 ounces, maybe 2 ounces sit in the compressor. The rest of the oil is spread throughout the AC system. When you replace a component, whether it's an evaporator, a condenser, we have to figure out how much oil should be put back in that new part that you put on. Most manufacturers will tell you it's about 1 ounce for every component. Maybe they say 2 ounces for every component you replace. Again, you're looking at service information for that answer. But compressors are a little bit different because at any given time there may be more or less oil in the compressor. Here's how this is done. We take the compressor off that we're replacing. We tip it over and we allow the oil to drain out. And we measure that amount of oil. Okay, we're using a graduated cylinder, something that can measure volume of fluid. And based upon how much oil we take out of that compressor, we may put that same exact amount of oil back in the new compressor, or we may put in a little bit more oil. For instance, Chrysler, and I'm going to show you this service information at the end of this video, Chrysler designates that you measure the oil. If it's not 2 ounces, put 2 ounces in the compressor. Okay? If it's less than 2 ounces, again, put 2 ounces in the compressor. If it's more, put the amount that was in the compressor into the new compressor. Okay? Again, hopefully that wasn't confusing. The document that I'll put on the blackboard will also show how this is done. Now, be very careful. Some compressors that you buy, some brand new compressors, come with oil in them. We don't know how much oil that is. It could be 2 ounces. Some compressors come with the amount of oil that the entire system needs. So it may come with 5 ounces in it. So what you have to do is not only measure the amount of oil that comes out of the old compressor, you have to measure the amount of oil that comes out of the new compressor, just to verify that that's bone dry before we put our known measured amount inside the new compressor. Again, hopefully that's not confusing, but the wrong amount of PAG oil, compressor oil, refrigerant oil in a refrigerant system can affect refrigerant performance. It can affect AC system performance, and it can affect the longevity of our AC compressor. All right, this is assignment number 3 for this course. I will probably be posting assignment number 4 next week, and I believe the course wraps up after that. If you're having any issues, please email me, call my office, leave a voicemail. I will be sure to get back to you to make sure that we're giving you the assistance you need. All right, take care, everybody.